Okay, so now that we've finished the more visual representations of data, we still have one more to go, which is the box plot. That's more included in this dot point in the study design more than the previous one, which was sort of the histogram, the dot plots, and the stem plots. We're now looking more directly at just the numbers themselves, without worrying about what sort of diagram or what sort of visual representation that they can take on. Now, before we can sort of do a lot of manipulations and analysis with data, we have to get a few definitions in there so that when they come up in the future, we all know what they are. Now, you'll go through these in class with a bit more detail, including sort of how to work them out in different scenarios, but I will go through the basic idea and then we can apply it in the future to different questions. So now these aren't going to be directly asked, like there's not a question that's going to ask what is the mean of the data set, okay? That's just, because it's just a basic algebra calculation and it doesn't really test your understanding in any way. So we will mainly be focusing on four things: the mean, median, mode, and range of a series of data, which is also given by center and spread, okay? Center is just essentially the median, and the spread, we can interpret that in a few different ways. So the range is a form of spread. You'll see what I mean. So let's get on with the mean, okay, the mean of a set of data. Now, the mean, more commonly known to most people, would be the average. You're taking the average of something. Yeah, so you have a set of data, but we want to know what is the average value. What is sort of, yes, we have numbers like 1 and 15, but what is sort of around the middle and it's sort of balanced out, taking into account of everything. Now, in this data set, we have 16 numbers. So we're just going to say that n equals 16, okay, just to represent that we have 16 numbers in the data set. So this here is our set of data. Now, the calculation for the mean goes by the mean is equal to the sum of all the numbers divided by the amount, the number of data, or I shouldn't say the number of numbers, but so it's basically 1 plus 1 plus 3 plus 5 plus 5 plus 5, adding all these numbers together and dividing it by 16, okay? So this just means sum, okay? So you're adding up all the numbers in the data set and dividing by how many they are, okay? So add all numbers divided by how many there are, okay? So that's essentially what the average is. So it's sort of, the average is one of those things where most people like to say it in a very casual way. And to most people, it's quite an accurate representation of the situation. So, if you have a group of friends talking about their, salary, then we can all agree that what we would be most interested in is, well, what is their average salary, okay? So combining them all together, and then sort of, if this one earns a bit more, this one earns a bit less, they compensate for each other. Whereabouts roughly would I be looking at? Sorry, a more like a certain job, a certain profession. So if you have a bunch of doctors sitting together, how much do they earn on average? Okay, and it's sort of, people generally think that it's a good representation of the scenario. So if we added these numbers up, the average could be 7 or 8 or 7.5. So that will give us quite an estimate of where the middle will be. But it does get impacted by extreme values. Okay, so if you had let's say like 10 students in a class, right? And one of them happens to be working a very nice job for some reason or the other, and they happen to be earning a lot. So that's going to mean that your average, so if you take the average income of these 10 students, because you have one really high income, therefore your average income is going to be very high as well. And in that case, you can't say that on average students make $1 million. Okay, you can't say that on average, each student makes $1 million. It doesn't work like that. You could have 5 out of 10 students making nothing, but that really wealthy student, they could be making $10 million a year. So that's going to drag your average right up. Or on the opposite end, most students could be making about 200, 300 a week, where you have most sort of one person making nothing, so that's going to drag the average down and make it seem like that students make less than they actually do. So the mean is very easily impacted by extreme values. So that's why we tend to use, when we're analyzing data, we tend to use the median as a form of a way to find the middle value. So having a lot of properties down the block, this is just another example, having a lot of properties around the block, you have one property that's, I don't know, $3 million and the other one which is just normal price, so it's going to go up. The average will go up, making this area seem more valuable. But if we take the median, which is the middle number, it's not going to be affected by really extreme values, okay? Because extreme values are normally like 1 or 2. In other words, they're present in very small numbers, and the median is not affected by that. So the median is essentially the middle number, okay? So it's the number in the middle, however way you like to put it. So in this case, we have 16. We have 16 numbers in this data set, n equals 16. So the middle of 16, if you divide 16 by 2, you have 8, okay? But that doesn't work because for something to be in the middle, each side of it will have to be exactly the same. So if you count to 8, you have 1, 2, 3, 4, 5, 6, 7, 8, and say, because 16 divided by 2 is 8, this is the middle number. Well, that doesn't work because you have 1, 2, 3, 4, 5, 6, 7 on this side. You have 1, 2, 3, 4, 5, 6, 7, 8 on one side. Okay, so that doesn't actually work because it's not exactly middle, since it's 50% of the data. If it was exactly middle, 50% of the data will be on one side of that number, and 50% of the data will be on the other side of the number. So a more accurate middle will be in here. Okay, this is what will be the median. Okay, now there is a formula to work out the median. It works out the position of the median, and that is to say n plus 1 divided by 2. Okay, this position. So in our case, since n equals 16, we have 16 plus 1 on 2, which equals 17 on 2, which is the 8.5th position. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8.5, and that's where the position is. Now, if if it's an odd number, sorry, if I should put it like this actually, if median lands at 0.5, because remember this works out the position, okay, of the median. Now we want to know what the value of the median is. All we know is that the median is here, but we don't know what the value of the median is. So if the median lands on 0.5, sorry, so 8.5, 9.5, 10.5, so something 0.5, then we take the two numbers on each side and the average. Okay, so what we're saying is that the median here is actually just the average of the two around it. So it's just the average of 6 and 7. So remember we said that the average would be equal to 6 plus 7 divided by 2, okay? So the sum of them divided by how many there are two numbers, the number 6 and the number 7. So the average will come out to be 13 on 2, which is 6.5. And if we look at the data up here, it makes sense. 6.5 is halfway between 6 and 7. Now, this is just a very simple example. Normally, when you get questions, it's not going to be that easy, but the general rule still applies. So that's if the median lands on a 0.5, so halfway between two numbers. Now, if the median lands on a number then that number is the median value, okay? So let's say that we scrap 15 and that's not a part of the data set. So now we have n equals 15, okay, which means the position of the median, I'll just say median position will be 15 plus 1 divided by 2, which will be 16 on 2, which will be the 8th position, okay? So 1, 2, 3, 4, 5, 6, 7, 8. So there's 7, 1, 2, 3, 4, 5, 6, 7 on one side, and then 1, 2, 3, 4, 5, 6, 7 on the other side. So 6 in this case will be the median. Okay, if n equals 15. Okay, so now that we've landed on the whole number, that number is the median. But if you land in a 0.5 position, then you have to average the two numbers on either side. So the mean and the median is probably the more difficult ones out of the four that we're going to do today. Now the other ones we were going to do is the mode. The mode is probably the easiest. It is the most frequently occurring, okay, or it just appears the most. That's literally what it is. So if you look at this data set, you have two ones, so there's two of the ones, 1, 3, you have 4 5s, so you have two of them here, one of them here, you have 4 5s, 6, 7, 2 8s, 9, 10, 13, 2 13s, and 15. So obviously there are 4 5s, and therefore the mode equals 5, okay, i.e. 5 is the most most frequently occurring number. 5 appears the most in this data set. That's can't say much about it. That's all that is. That's all there is to it. And finally, we come to the range. Now, the range is not difficult either. All the range is the maximum value, minus the minimum value, okay, which is the same as saying largest minus the smallest. So the largest value here will be 15, and the smallest value here will be 1. So the range for this data set equals 15 minus 1, which equals 14. Okay, that's quite straightforward as well. You find the largest number in the data set, you find the smallest number in the data set, and you subtract them, and that's the range for the data set. Now, a key point to note here is that for the sake of explanation, all these data have been organized nicely. Okay, so they're all in chronological order from smallest to the largest. Now, if they were not in this sort of order, the range will be okay, because you can look through and find the largest number and the smallest number and subtract them still, okay? They don't need to be at the ends for you to be able to do that. The mode will be okay, because you can still go through and find what number occurs or what number appears the most, okay? Them not being in order isn't going to stop you from doing that. Finding the mean, it will still be okay, because you are just adding everything together, and it doesn't matter what order they're in. When you add them together, you're going to get the same total. So the mean will be okay. The only thing that will be impacted here will be the median, okay? If they were not in chronological order, you cannot do the median like this, okay? So for median, it has to be in I cannot stress this enough when doing this, that it has to be in chronological order in order for you to find the median. Otherwise, it will not work. If you count to the 8th position, and because you have a list, you have the number 15 in there, and your median happens to be I don't know, 10.5, but in reality, the whole data set is basically from 1 to 5, but you just have a 15 laying there randomly. So, if you happen to come across it and you get a median of 10.5, well, it doesn't really represent the middle when everything else is just 1, 1, 2, 3, or 4, or 5. Yep, if that makes sense. So it has to be in chronological order for this, for finding the position and then finding the value to occur. That is very important. On the exam, they'll give you a list of numbers, which will just be completely random. It will be 67, 74, 83, 62, 95, 73, and they'll be like, find the median. So most students, they'll just say, okay, so the median should be here. This should be the median. Let's take an average of 62 and 83, and we're done. But no, you have to order them from in chronological order. So 73 has to come first, followed by 67 comes first. No, it doesn't. 62 comes first, followed by 67, followed by 73, 74, 83, and 95. You can see that I got a bit confused there because looking through these numbers is quite difficult. So make sure you double check that they're in the actual chronological order before you start doing anything, okay? And it only applies to the median, everything else is fine. So I hope that it has been somewhat clear. Now, this isn't meant to go through these things in a great detail. Obviously, your classes will cover them, and they'll give you a lot more practice at different sorts of questions. But this will just help you revise and sort of get a bit more grip on the definition of it. But then again, this isn't the most sort of difficult definitions to remember, and a lot of you would have come across it in the earlier years of mathematics. So I think this topic should be fine, and when I mention them in future videos, I think it should be fairly clear that what I'm talking about. So that's all for today, and I'll see you in the next video.